Okay, Dick, can you see Autodesk Building Systems?
Yes, I can. Looks good.
Okay, great. All right. Well, for those of you who are familiar with Autodesk Building Systems, this should look like a very familiar environment for you. And Content Builder is actually launched from the MEP Common pull-down menu. And when you launch Content Builder, this is the dialog box that you will see. First thing you need to do is you need to define where you want to place this part inside of a catalog. And the way that you can do that is you're first going to decide what domain or what type of part this is going to be. And in this case, we're going to make a duct fitting. So we're going to use the duct part catalog to store that in. It is also going to be a multi-shape because we're going to make a round to rectangular T. And when we get into that catalog, you'll notice that we have different types of multi-shape parts. And in this case, we're going to focus on a slip joint part. And as we begin to move down the tree of our catalog, we can identify exactly where we want to place this. And where we want to place this is actually in the slip joint T's folder. And you'll notice that I have an option down here, which is the second button over on this particular dialog, that if I hover over top of it, it says New Parametric Part. And this is what I'm going to click that will allow me to get into the parametric building environment. Okay, now what I'm going to do is it's going to ask me to give it a name. And in this case, we're simply going to call it Round to Rectangular T Example, just to keep it different. You can name that anything you want. It could be custom for a manufacturer. You could also have a unique description. By default, your description is the same as your name, but you could certainly type in here something else. Example for webcast. Okay? And we simply say OK. Oh, it's already, now, it says it's already in use. So in this case, we're going to say it's an example 2. And simply say OK. And the environment that you will see now is you get what looks like the active environment that you would typically work in building systems, but you also have what we refer to as a part browser over here on the left side of your screen. What you want to do is you want to navigate, and when you're building your part, focus on using this part browser as a guide to step you through the creation process. You'll notice up here what I have is the first part here is the name that I gave this. Round to Rectangular T Example 2 was the name that I gave this part. You'll also see that I have some categories underneath this. I have part configuration, modeling, connections, and size parameters. This is the order when you begin to develop a part that you want to begin to define information about this part. Most important is the part configuration. The part configuration is what determines the overall location in a catalog, the type of part it is so that the part knows how it's supposed to behave inside building systems. Also subtype and domain, whether it's a duct or a pipe or whatever it might be. In this case, the first part we have here was the description that I gave for the part. I have the part family. In this case, it was a duct part family that we had chosen. It might, if I had decided to do a pipe fitting, this would say pipe at this point. These are actually hard-coded when I initially define this part through the front end of Content Builder. Now at this point, what I can do inside here is I need to define a part, and I can also define a type, and also define a subtype. If I double-click on the undefined type, you'll see the list of available types that are currently built into building systems. And in this case, I want to select it as a T. This type is what's going to help define what this part is when we begin to use it inside building systems. I can also define a subtype if I want to get into more specifics. I could enter in my own here, or I can select from the list. In this case, we'll say that it's a round to rectangular branch transition. Okay. All of those have to be defined in order to even begin part creation. With that defined, what I can do is I can actually begin to get in to model my part. And to model my part, the first thing that you're going to come across are going to be these 4 folders that are underneath modeling. And when we refer to modeling a part consists of putting together features that have specific relationships to each other that define the behavior of the part. Okay, so you're going to hear a couple different words. You're going to hear, when we talk about modeling, you're going to refer to the actual building of the part. You're also going to hear me use the term features. A feature is something that is being used in this specific model to define the relationship and to define the behavior of this part. So features and model, that's the terminology, just to put everybody on the same playing field. And the first thing that I want to do is I'm going to add a work plane. And the reason I add a work plane is because I need to create a plane, an actual working plane, that I can begin to develop this part on. Now, I typically use default. There are a lot of different options that you can use. And if I click on default, what you'll see that shows up here is, if I go to my 3D view, you'll notice that I have 3 different planes. These planes, if I expand on work planes, are my typical X, Y, and Z work planes. And if I click on each of them in my part browser, you'll notice that they'll highlight on the screen. So everything that you're going to create is going to be associated with a plane. That is a very, very important piece that you need to keep in mind. And what I'm going to do today is I'm going to focus on using the XY plane and show you why in a minute. And what I can do at this point is if I right-click on any of the planes, you'll see that I have a visibility option. I can simply say, you know what, I'm not going to use these. Let's turn them off so I'm not going to see them right now. So I'm going to focus on the XY plane. I can come back over. I can select my top view. I just want to work in a 2D plan view so I can understand how this part is going to fit together. Okay. The next thing that I want to do is I'm going to actually begin to sketch out my part. Now, the way that I'm going to do that is I'm going to use some basic geometry. And geometry, such as points, lines, or circles, are the basic building blocks for defining your shape and size of your part. Now remember, I told you that everything that we do is going to be associated to a plane. So all of these commands are from the right-click menu of my specific plane that I'm working on. So you'll see here that I have Add Geometry. In this case, I'm going to add a line because I want to begin to draw the center line of my main piece, the main part of my T, as well as the branch. So I can simply click on Line, and it's just like drawing a line in AutoCAD. I'm going to come over, and if I read what's on my command line, another very important tip to point out, it's very important to follow what is happening on your command line. It's going to say, pick start point. So I'm going to pick a point. I'm going to actually use my ortho because it will help me maintain the direction. I'm going to continue to draw exactly where I want the main part of my T to go. When I am finished, I simply push Enter. Now I can do that again to put the branch on. So I can say Add Geometry, Add a Line, and somewhere here in the middle there's going to be a branch that's going to come out. Now when I drew this, you'll notice that I added small pieces on either end of this. Now remember, I said that it's very important for you to understand the dependencies when you are building a part. Typically, fittings, as in this case, they have what's referred to as a shoulder length. And that shoulder length allows the proportions to be maintained when this part gets created. So for instance, if the branch coming out was a 10-inch rectangular branch coming out of maybe a 12-inch, it will make sure that the proportions in here are truly going to make that part work. So what we do is when we actually build this part, we take that into consideration. And when we get a little bit deeper into the development of this part, you'll see that I'm going to start to add some dimensions to those shoulder lengths. Okay. So the next thing to do is I have my basic center lines, but my center lines don't understand how they're, what the relationship is between the main part of my T and its branch. So the next thing that I can do is I can actually add some constraints. And the constraints are used to help define the shape or the size. They enforce the rules that you want this model to obey. For example, I know that the point at the end of this branch is going to be the same point on the center of this main trunk, if you want to call it that, or the main part of the T. And so what I can do is I can use a coincident. I'm going to zoom in so you can see this, a coincident constraint, and I'm going to constrain my top point to this line simply by clicking on the point and clicking on the line. And you'll notice that what happened is the point automatically got moved to that line. So now this point is essentially locked to wherever this similar point would be on that line. Okay, so constraints actually create rules that help this parametric part to work. Okay? Now some other constraints that I can add, I also know that this particular part of, or feature, I'm going to use the word feature, this particular feature is also going to be parallel to this feature, parallel to this feature, and parallel to this feature. But I know that the branch needs to be perpendicular. So what I can do is define those as constraints. And again, I will right-click on the XY plane. I will come down to my constraints. I will select a parallel constraint. You'll notice that I have a variety of different constraints, tangents, perpendicular, parallel, equal distance. All of these are different constraints that I can apply to the geometry to begin to help define its shape. It's the rules that are going to make this parametric part work. So I'm going to select parallel, and I'm going to select that this segment is going to be parallel to this segment. And if I expand what's happening under XY plane, you'll see that I'm beginning to build up all of my constraints. You'll see that this was all my geometry that I had created. If I select on any of this from the part browser, you'll see that it will highlight so I can see exactly what part that is or what feature that is inside this model. I can do the same thing with my constraints. Now I just constrained the parallels, and you'll notice that when I click on this, you'll see what's parallel. When I click on the coincident, you'll notice that the point is coincident with that. So it's beginning to build all of these rules inside of this model for me. Okay. Now the other one, I want to continue on, and we're going to do some additional constraints here. I also said that we needed an additional constraint for parallel. That was going to be the other side of this. So I want to make sure that this stays parallel to this feature. And I also want a perpendicular. I want to make sure that my branch always stays perpendicular to the main part of this T. And in order to do that, I can select Add Constraints. I can come down to Perpendicular. I can select Perpendicular to this. It's going to always maintain perpendicular to that piece. And if I come down and select on my perpendicular, you'll notice that those are the two features that are now constrained to always maintain perpendicular. Okay? And the last constraint that I want to add here is going to be another parallel constraint, which is going to be this shoulder length to its branch. All right, so let's take a quick review of the constraints. And I'll check and see, hopefully everyone is following me so far. We created coincidence between the point and the main branch. We created a parallel to maintain half of that main branch, the other part of the parallel for the main branch, perpendicular for the branch coming off, and also an additional parallel. Okay, so what we did there is we constrained our geometry to maintain a specific shape to begin defining this parametric part. And let me take a break there for a second. And Jason, are there any questions so far?
There are a couple questions, Laura. One of them was, when you started from the menu over there and you right-clicked and said Add Geometry and you picked a line, can't I just use an AutoCAD line for that instead of the way you did it?
No. One of the really important things that you want to make sure you do is the typical line work that's inside of AutoCAD is not going to be the same line work that we're using here. Content Builder is almost like a separate program that is working inside of the Autodesk Building and Systems environment. So you want to make sure that whatever you use, geometry, and that's the same for dimensions, when we get into talking about dimensions, we want to make sure that anything that we use is solely coming from our part browser. Very important to keep that in mind. Anything else?
There was another question about there seem to be a lot more constraints than the ones you've just added here. Where did those come from?
Oh, those actually, good question. If I highlight on these coincident points, you'll notice that as I drew my lines, a lot of what's going to happen is the start point and the end points are going to become by default coincident. The Content Builder actually defines that for me because of the way that I drew my line. So all of those points initially, as I stepped through these, you'll see that all of those became coincident points, and they were all the start and end points of my lines. Anything else?
Okay, there was one more question,
Sure.
and it was about whether or not you need to, when you're defining your constraints, do you need to pick objects in a certain order, or does the order in which you pick objects matter?
The only reason why there really is no forced reason why you have to specifically pick them in an order. The best rule of thumb that we recommend for people is that they apply the constraints in a logical order. What I mean by that is that I knew that this whole line needed to maintain, there was 3 different features inside this, and I knew that all of these needed to maintain to be parallel to each other. So I basically constrained this whole line first. And then I went down and I maintained my the perpendicular between the branch. Always remember, though, that you can always come back and review what you did based on adding your constraints. When we get into doing dimensions and some of the other things that we get into doing to help define this part, there will be some kind of rules of thumb that will help you. The order of how you do things will help. Trying to think if there's any other rules of thumb I can kind of give you on constraints. The one thing that you do want to keep in mind is that you want to use a minimum amount of constraints. Don't over-constrain your object. You'll notice down here on the bottom that I'm still under-constrained by 6 dimensions. Well, constraints are only one way of helping to define the part. The next thing we're going to get into is actually doing some dimensions, and that's a second way. So when you start out, you're going to basically, rule of thumb is constrain it on the basic way that you want to define this part. As the part begins to develop, you'll see if you need to constrain more things. So start simple, and then work your way up as it gets a little more complicated. And you'll see how that's going to kind of play out as we step through this. Anything else, Jason?
I think that's it for right now.
All right. Hopefully that was a little clear for everybody. It gets a little confusing, but bear with me here and we'll work our way through this. All right, so that was constraints. The next thing that we're going to get into, and the next step that you're going to see, is we're actually going to begin to add some distance information that's going to be on here. And one of the ways that we can do that is with what we call an equal distance constraint. And what I want to do is I want to maintain some equal distances here for the parts, for the different features, the lines that I had added to this. So my equal distance is, I know that the distance from this point to this point, I want to make sure is always going to be the same distance from this point to this point. Now, somebody had asked, was it important how I defined those constraint points? The only thing that was important was that I did a start to finish of this and a start to finish of this. So it didn't matter if I went from point A to point B or from point A to point B, as long as the constraint was defined from a start to an end. That would work. The other constraint that I want to add in here as well is going to be an equal distance constraint. Comes down to equal distance. And I want an equal distance for my shoulder length as well. So this shoulder length here, as well as this shoulder length. And you'll notice that as I'm defining them, it will move. I'm not concerned at all about what the actual physical distance is of these lengths at this time. I can define that at a later time. So don't get yourself hung up on, oh, this needs to be a lot longer or this needs to be a lot shorter. Just focus on the proportions at this point to make sure that you can define the actual behavior. And the last one that I want to put in here is I also want to make this shoulder length equivalent to these two. So I can come back in and add one final constraint, which will be an equal distance constraint, and I can use either. I could, again, use this one, or I could have used this one, but it's going to be the same as that. So you'll notice that all three now of my shoulder lengths are equal distance. Okay? All right. Now let's move on to the next thing. What I've done now is I have my basic geometry in here. I have some basic constraints to maintain equal distance, to maintain parallel, and to maintain perpendicular for the shape of this part. The next thing I want to do is begin to define the round and the rectangular portion of this. I know that this main part of the T is going to be round, and I know the branch is going to be rectangular. And the way that I do that is I'm actually going to use what's called a profile. Now, a profile is essentially a two-dimensional outline of a geometric shape. And what that profile does is that profile is going to associate the constraints that I defined to the actual geometry. I'll show you what I mean by that. First thing I'm going to do is I'm going to come back to my plane. I'm going to come down. I'm going to say Add a Profile. First one I'm going to add is going to be a circular profile. I'm going to select a center point, drag it out to some distance. Remember, distance doesn't matter at this point. And I'm also going to add in a rectangular profile because I know I'm going to need two different profiles. So we'll come down, we'll add a second profile. This one's going to be rectangular. Okay. Now, remember when someone asked me about all the different constraints, you'll notice I have, for my rectangular profile, for all the different types of geometry, rectangular profile, you'll notice that I have 4 points and I have 4 lines. All right. For my circular profile, I just get my one circle. Okay. That's the geometry of these specific profiles. And what they've also defined for me is, again, you'll notice that my constraints have grown significantly. Here were the equal distance ones, which were the last ones that I added. But now you'll also notice that I have more because when I added that profile, it created constraints by default. It knew that it was a rectangle. It knew that these points were coincident. It also knew that these particular lines are perpendicular, those lines are perpendicular, and so on. So when you're working with profiles, the profile actually is making that relationship between the geometry and the constraints for you. Okay? So now what we're going to do is I want to associate this circular shape to being this part of my T and the rectangular shape to this part of my branch. All right? Now this is where we're actually going to begin. You're going to see the development of the 3D portion of our part. All right, the first thing that I'm going to do is, in order to do this, I use what's called modifiers. And if anybody's familiar with AutoCAD, building solids or working with mass elements, there's extrusion tools. There's, you can actually create a circle and extrude it up a specific height. Those are similar things to what we refer to as modifiers. A modifier enables you to create a three-dimensional feature based on that profile. So what I'm going to do is I'm actually going to come down to my circular profile, and I'm going to add a path. And the path that I want to use for that is actually going to be this segment. I want this circle to go this across this path. And if I flip this, you'll see that that is exactly what happens. It took this circle and created a modifier. This is a modifier that I just clicked on to go across this path. Okay, so that's the relationship between taking the 2-dimension of a profile, applying it to a path in this case, and it applies and it creates a 3-dimensional shape. Right? And if I go back here to the plan view, I'm going to continue to do that for the rest of my pieces. So I also want to apply this same circle, and I do that by clicking on the circular profile, saying Add Path. So I want this geometry, and it's going to ask me how many path segments I want. Oops. Let me undo that piece. Not what I was looking for. Clicked on the wrong one. Go back here to our work planes, back underneath this one. I want to go to my circular profile. I want to say Add Path. The geometry that I want to pass this on is...
Hey, Laura.
Yeah?
It already knows the geometry. It just wants the path.
Right. That's what I was doing.
Okay.
I want the path, which is here, and it's going to continue on down. Now, I'm also going to apply that to the third one. So I'm going to select on my circular profile, say the Add Path, and you'll notice it highlighted it, and now I have all 3. And if I turn to 3D isometric view, you'll notice that I have all 3 modifiers here for that part of my T. Okay? Now I can also do the same for the rectangular portion. And what I want to do here is, this is actually going to be the transition that I'm going to be creating. And in order to do that, I can actually click on my modifier. If I click on my circular modifier, what I can do is say Add Path. And this is initially going to start out here as being circular. Oops. And let me back up one step, because that's not what I wanted to do. Sorry about this. I lost my place. Okay. What I want to do here on my modifier, I'm going to select the path, which is going to be segment 4. Click on my modifier. The modifier here. And I want to add, the transition is what I'm going to add. So what I can do is, I'm going to say Add My Path. And my first path is going to be segment 4 here. And it's going to ask me for my start profile. And my start profile I want this to start at is going to be my circle. And my end profile is going to be my rectangle. And you can see here that what it did is it put in my transition. The difference between what I did right here is when I clicked on the circular profile, by default, it knows that I'm using the circular profile. If I click on my modifiers down here in the part browser, what I have is different options that allow me to create the transition, to create a different type of path and use multiple profiles within that path. And that is the difference between the 2 ways that I picked to add the modifiers that were in here. And the next thing that I want to do is I want to apply my last modifier, because I want this line to be a complete rectangle. So in this case, I can go back up to my rectangular profile. Since it knows that it's a rectangle, simply say Add Path, and you'll notice that I've applied that to the end as well. If I look at this in the ISO view, you'll see that I now have the 4 profiles. I'll select them all here. I have the transition one, and I also have the rectangular one. So my part is beginning to take shape based on those basic pieces. All right, and let me stop here because I was slightly confusing with the way that I stepped through that. So, Jason, are there any questions? Did I lose anybody through that?
There were a couple questions actually earlier on, just as we were finishing up the other section, about you used a coincident constraint rather than a midpoint constraint for the one kind of in the middle of the main portion of the T.
Yep, right in here.
Yep. Is there a reason you didn't use a midpoint?
I didn't use a midpoint because I'm actually going